you ever wondered how people figure out the annual inflation rate on something like a house? You buy it for one price, and 5 years later, it's worth way more. How do you find that yearly percentage? It seems kind of complicated, right? Well, it turns out the answer is hiding inside a really powerful piece of math that we are going to break down today.
And we're going to do it by diving into the world of radicals and rational exponents. I know, that might sound a little intimidating, but stick with me. By the end of this, you'll see how these are just simple, really elegant tools for understanding the world around us, from, the size of a beach ball all the way to your finances.
So here's our game plan. First, we're going to start with the basic building blocks, these things called nth roots, and then we'll practice finding them. After that, we'll see how roots are connected to something called rational exponents, use them to solve some problems, and finally, we'll bring it all back to solve some actual real-world stuff. Okay, so first things first, what on earth is an nth root? Honestly, just think of it like being a math detective. You're trying to find the original number, that core building block, that was multiplied by itself a bunch of times to get you the number you're looking at now. So here's the official definition. For some number a, its nth root is just whatever number you multiply by itself n times to get back to a. You actually already know some of these. A square root is just a second root, and a cube root is just a third root. See? Not so scary. Now here's where a super important rule comes into play. Finding a real root all depends on whether n, that little number we called index, is odd or even. If your index n is an odd number, you're always going to get exactly one real answer. But if n is even, things get a little trickier. You might get two answers, one, or maybe even none at all. Why? Well, think about it. Any real number multiplied by itself an even number of times is always going to end up positive. All right, enough with the theory. Let's put this into practice and actually find some of these roots ourselves. This is a perfect illustration of that odd versus even rule. So for the cube root of -27, our index n is 3. That's odd. So we're looking for that one number that times itself 3 times gives us -27. And that number is -3. But now look at the fourth root of 16. Our index n is 4. That's even. And here we get two real answers. Both +2 and -2 work, because when you raise either of them to an even power, that negative sign just vanishes. Okay, your turn. Time to test this out. Take a look at this problem right here. What do you think the cube root of -125 is? Remember that rule for odd indexes? Go on, I'll give you a second. And the answer is -5. Because n is 3, which is odd, we knew there was only going to be one real root, and yep, -5 times -5 times -5 gets us right to -125. Awesome. Okay, you've totally got roots down. So now, let's get to the second half of this, rational exponents. This might look brand new, but I promise you, it is just a different way of writing down exactly what we've already been doing. And here it is. This is the aha moment. On the left, you see the cube root of 27 written with that little radical symbol. On the right, you see 27 raised to the power of 1/3. These two expressions mean the exact same thing. A fractional exponent is just another way of asking for a root. The number on the bottom of the fraction, that's just the index of the root. So what happens if the top of the fraction isn't a 1? Well, an exponent like m over n just combines two steps we already know how to do. The bottom number, n, tells you which root to take first, then the top number, m, tells you what power to raise your answer to. That's it. So now that we have this powerful new way of writing things, let's level up our skills and use it to solve some more interesting expressions. This is really where it all comes together. Let's break this one down. To figure out 16 to the power of 3/4, we just follow a simple two-step process. First, we deal with the bottom of the fraction, the 4. So what's the fourth root of 16? It's 2. Great. Now we deal with the top of the fraction, the 3. We take our result, 2, and raise it to the third power, which gets us 8. See? It's just a sequence of 2 easy steps. All right, let's do one more. Your turn again. Using that exact same two-step process, what is 256 to the 3/4 power? Take a second and think it through. Did you get 64? That's it! Step 1, the fourth root of 256 is 4. Step 2, 4 to the third power is 64. You are totally getting the hang of this. So we've learned all the mechanics, but who cares? What is this actually good for? Well, let's bring this all back to where we started and see how this math helps us describe the actual world around us. Check this out. If you want to find the radius of a sphere, like this giant beach ball, from its volume, you use this formula. And look right there, at the very end, in exponent of 1/3. To find the radius, you literally have to calculate a cube root.
And when you plug in all the numbers for the volume and for pi, and then you calculate that rational exponent, you find out the radius of that beach ball is about 3 feet. This math gives us real, tangible answers we can actually use.
And this brings us right back to our first question about the house. How do you find that annual inflation rate? Well, you use this exact formula. You take the final value, divide it by the starting value, and you raise the whole thing to the power of 1 over n, where n is just the number of years. It's a rational exponent. So after you plug in the house prices and the number of years and do the math, you find the annual inflation rate was about 3.3%. That seemingly complex financial question we started with, it's solved with the exact tool we've been practicing this whole time. So cool. So let's just do a quick recap. What are the big ideas here? First, an nth root is just how we find the original building block of a number. Second, rational exponents aren't some new scary thing. They're just another, often more useful, way to write down roots and powers. And most importantly, this isn't just textbook math. It's absolutely essential for understanding real-world things like geometry and financial growth. And that brings us to the end. But here's one last thought to take with you. Now that you actually know the formula for calculating an annual growth rate, what's the rate of your savings account, or your favorite stock, or even the value of a collectible you own? The power to figure that out is literally in your hands now. Thanks for watching.